This is going to be a short podcast, but I like the paper because it looks at blue foods, very relevant considering we are in the UN Decade of Ocean Sciences, talking about sustainable ocean exploitation and other things, and part of the Sustainable Development Goals also fit into these. And this paper also is different in the sense it doesn't try to project into the future with all their uncertainties, but instead just points out the various vulnerabilities that are created for the blue foods for many of the countries, and a global map of the vulnerabilities to human-induced environmental change. So I figured it's a nice little paper to go through. Let's read the abstract again. Global, again, in the sense I always read the abstract when the topic is not very technical, in the sense of equations, models, and so on. Global aquatic or blue foods, essential to over 3.2 billion people, face challenges of maintaining supply in a changing environment while adhering to safety and sustainability standards. Despite the growing concerns over their environmental impacts, limited attention has been paid to how blue food production is influenced by anthropogenic environmental changes. If it's way out there in the open ocean, you think maybe it's somehow protected from our impact. Here we assess the vulnerability of global blue food systems to predominant environmental disturbances and predict the spatial impacts. Over 90% of the global blue food production faces substantial risks from environmental change, with major producers in Asia and United States facing the greatest threats. Capture fisheries generally demonstrate higher vulnerability than aquaculture in marine environments, while the opposite is true in freshwater environments. While threats to production quantity are widespread across marine and inland systems, food safety risks are concentrated within a few countries. Identifying and supporting mitigation and adaptation measures in response to environmental stressors is particularly important in developing countries in Asia, Latin America, and Africa, where risks are high and national response capacities are low. These findings lay groundwork for future work to map environmental threats and opportunities, aiding strategic planning and policy development for resilient and sustainable blue food production under changing conditions. With ocean warming, there are direct temperature effects, there is acidification effects, sea level rise effects, deoxygenation effects, of course pollution effects, and so on and so forth. So let's look at some of their analysis. Top 5 countries with the highest exposure to anthropogenic stresses. So we are looking at A and B. So exposures here are in terms of production quantity here and production safety in B. Scores were standardized and should only be compared within stressors. So you cannot compare production quantity stressors to food safety stressors. Seems obvious, but still. So just see that the scale here goes from 0 to 1 in both cases. So when you go up this way, you are going from low to high exposure intensity in food production and exposure intensity in food safety. So here we have quantities that affect. There are the stressors, severe weather, and here we are talking about freshwater, marine, and both. That's the color code here. Okay, so China, highly vulnerable. India, highly vulnerable in terms of exposure intensity for production quantity, and US less so, but still Australia, Indonesia, and you have for marine, so that's for freshwater. This is for marine. You have Japan, which is very heavily dependent on fish as a main diet. Australia is up there, Philippines, Mexico, China. So you know that when Australia is fishing a lot, it's probably selling it, exporting it, and so on. It's not a big fish eating country. Solomon Islands, of course, fishing and exporting, so they are subjected to sea level rise concerns in food production quantity exposure. So very high exposure here. Similarly, all the islands, Micronesia, also Finland, Estonia, and Palau. So you can go and read where these exposure intensities come from. But if you go to these latitudes of Finland and Estonia, you're almost in the very close to the polar circle, where polar amplification is causing tremendous warming and loss of snow and ice and so on, which affects the the waters and ecosystems there. Okay, so warming, Russia and Greenland are way up there for production quantity, impacts Belarus, Ukraine, and Kuwait. For warming in freshwater, this is for freshwater, this is for marine species, Russia, Canada, Greenland, Iraq, and Kuwait as well. Okay, let's look at the food safety exposure intensities. So you have pesticides for freshwater, marines, POPs for freshwater, and so these are chemicals that you don't want. So somebody is knocking on the door. Sorry about that. I always get people knocking on the door when I'm recording because I'm doing this in my apartment. My office is not a very exciting place, so I tend to sit at home. Okay, sorry. Where was I? I am still here. Bring up the pointer. So we are looking at pesticides in freshwater systems and marine systems. So you have Bosnia-Herzegovina, and there are lower exposure intensities, but still it's there for Poland, Belgium, Bangladesh, and Estonia. And you have persistent pollutants that are a concern in terms of food safety for all these countries: Eswatini, Albania, Montenegro, Lesotho, and Greece, and also the same chemicals in the marine ecosystems for Montenegro, Belgium, Albania, Togo, and Ghana. Again, remembering the exposure intensity increases from left to right. Looking at a few more, I'm not sure I'll read all of those, but I will read the kind of stressors and the safety issues. So you have acidification, diseases, eutrophication. If you don't know what the eutrophication terminology, I have podcasts on those in my ocean course that you can look up. Basically, it's excess nutrients which produce fish kills and other things because of the depletion of oxygen by excess blooms. Hypoxia is where you have low oxygen invasion, so invasive species, parasites, so marine, freshwater, and both systems, and precipitation runoff can cause big problems for countries like Papua New Guinea, Cambodia, Vietnam, UAE, and Djibouti as well. Okay, in terms of food safety issues, you have antibiotics and in freshwater and marine systems, bacteria in both systems, harmful algal blooms, mercury poisoning in both systems. So you can see mercury poisoning, which became big in the 1950s with the Minamata disease, nervous system failure or serious damage to the nervous system in Japan, Minamata Island, I think it is. But you can see mercury is a big problem for in terms of exposure intensity for Trinidad and Tobago, Bangladesh. So Bangladesh has low exposure intensity here in terms of, where was it? It was somewhere here. So in terms of pesticides, it's not bad, but it's very high in mercury. Of course, mercury is deadly dangerous as well. Many times you get warnings of fish that are likely to be mercury poisoned, so you can try to be careful. But you can see that there are many countries affected by food safety issues from mercury, both for freshwater and marine fisheries. So Congo and Grenada are bad. Trinidad Tobago is bad both for mercury in the freshwater and marine systems. Vulnerability scores of 15 blue food archetypes to anthropogenic stresses affecting production, quantity, and food safety. Confidence scores are provided for each archetype stressor. each archetype stressor assessment on the basis of the availability of evidence determined through the literature review and expert input. So we have freshwater, artisan, artisanal, commercial, and exchange. So you're looking at production quantity and food safety again. So looking at climatic and non-climatic impacts. Non-climatic are things like diseases, but they are related to climate change because warming tends to increase pathogens and disease pressures. Similarly, for parasites, warming matters as well. Invasion, which is related to often ballast waters and other things, eutrophication, hypoxia. But invasion can also be related to warming and deoxygenation, like jellyfish can take over an ecosystem when oxygen drops, for example. You have altered precipitation, warming, acidification, sea level rise, and severe weather events under climatic impacts on production quantity. For food safety, you have mercury, POPs, antibiotics, and pesticides. And biologically, these are chemical, these are biological here. Harmful algal bloom toxins like pseudonychia and domoic acid. You have brevitaxin, brevitoxin from, I think, Corynea brevis. So non-indigenous bacteria and indigenous bacteria. Here are the freshwater captures and marine captures and maricultures. So you have artisanal lakes, artisanal rivers, wetlands, commercial exploitation of lakes, cage finfish, pond crabs, pond finfish, pond prawns, and artisanal mixed, commercial benthic, commercial pelagic, and you have ocean ocean algae in mariculture, ocean bivalves, ocean finfish, and exchange ponds. Okay. So those are kind of very quick different scores. So you have high, medium, and low or none in terms of confidence. You have blue colors with sufficient confidence, partial confidence in yellow, poor confidence in this magenta color, and no confidence in a lot of these gray colors as well. Okay, so obviously I'm not going to read all of those, but it's a nice mapping of the food production quantity impacts from non-climatic and climatic factors, food safety impacts from chemical and biological factors on various types of captures here and mariculture. Finally, estimated impacts of anthropogenic stresses on global blue food production. So we are looking at standardized impact score, of course red colors being very high. So you have impact on quantity and safety again. So now it is as a global map which corresponds to what we already said. So impact on quality for freshwater and marine, you have highly impacted regions of Canada, Central America, and basically North America and Central America, let's say, with lower impacts on South America, and you have large regions with low impact scores over Africa. It's not a very fishing continent as such, but Europe is. You can see high impacts in freshwater and marine captures, both of these as well. And you have Asia here, this is in terms of food safety. So US and Canada also face food safety issues, and here South America, which was not bad in production quantity impacts, but has food safety issues. But India is high on both quantity impacts and safety issues. China is much higher on food safety issues, but also high on production quantity impacts in terms of these metrics we have been looking at. Similarly for marine and mariculture, and this is for production and food safety. This is for this is all impact on quantity, freshwater and marine capture and mariculture. Okay, so what's the did I miss something here? The 4 production systems included are freshwater capture fisheries, freshwater aquaculture, marine capture fisheries, and mariculture. So I should read carefully. This was capture, this was culture. Okay, sorry about that. In terms of food safety, again, freshwater and marine captures and freshwater and marine cultures. Okay, so lower scores here overall in terms of food safety than production quantity impacts, which is partially good news. But as we keep trawling more and more the bottom for production drop, then we tend to increase the impacts of potential food safety impacts on potential impacts on food safety as well. Okay, so quick run through, but you can read the paper to get more details, and they have a long list of references as well. Okay, see you in the next topic.